how many types of loads are there for the bridge-type step-down cycloconverters? In the previous section, we have discussed about cycloconverter, which has been traditionally used in very high power drives. These are mainly used for more than 1 megawatt where other drives cannot be used. Let's take an example of reversible rolling mill drives and ship propulsion drives for deriving the application of cycloconverters. Here we're going to study the last section of single-phase cycloconverters. That is a step-down cycloconverter with bridge-type construction. There are two types of loads which we apply on the bridge-type step-down cycloconverter, namely continuous and discontinuous loads. Here we'll focus on step-down cycloconverter. It converts the incoming line frequency to a lower frequency by the use of SCRs. The two bridge-type controlled rectifiers are connected in anti-parallel direction via 4 ideal switches. The time period of the ideal switches controls the output frequency, and the voltage can be varied by the firing angle of the SCRs. By using 4 switches, the grounds of both the converters are isolated. We've discussed earlier that converters require natural commutation, which is provided by AC supply. Here, during positive half cycle of supply, thyristors P1 and N2 are forward biased, and the first triggering pulse is applied to P1 and it starts conducting. But when the supply goes negative, P1 gets off. In negative half cycle of supply, P2 and N1 are forward biased, and P2 is triggered, which starts conducting. In the next cycle of supply, N2 in positive half cycle and N1 in negative half cycle are triggered. Thus, we can observe that here the output frequency is half times the supply frequency. Now, when a cycloconverter operates in non-circulating current mode, the control scheme is complicated if the load current is discontinuous. The control is simplified to an extent if some amount of circulating current is allowed to flow between them. In this case, a circulating current limiting reactor is connected between the positive and negative converters, like in dual converter. That is, two fully controlled bridge converters connected back to back in circulating current mode. This circulating current keeps both converters in virtually continuous conduction over the whole control range. This type of operation is termed as the circulating current mode of operation. The operation of the cycloconverter circuit is involved with both purely resistive and inductive loads. Thus, we can summarize as: